Hello everyone. In this video, we shall calculate the value of this infinite series using complex numbers. We start with the basic geometric series which we have learned. So summation of x to the power n from n equals to 0 to infinity for all valid x, which is mod of x less than 1, simply equals 1 upon 1 minus x. Now we would like to differentiate it with respect to x. So first write down the series and now differentiate on both sides with respect to x. And in doing so, the left hand side simply becomes n times x to the power n minus 1, while the right hand side becomes 1 upon 1 minus x whole square. Simply multiply by x so that we get n into x to the power n in the simple form and you get the right hand side. Now we can proceed to do double differentiation, and in second differentiation, we are going to repeat the same procedure. So again, you start off with the identity that we received, and now you differentiate both sides again. Now, again, after differentiating, we will be left with x to the power n minus 1 thing, and you can differentiate the right hand side by your own. Now, multiplying both sides by x, you shall simply get the value. And this is the crux of the whole problem. This is what we require. Now that we have it, we are going to introduce the alternating series because we noticed there was a minus 1 whole to the power n, right? Write down the series and now replace x by minus x. In doing so, we get the following series where you can see we already have a minus 1 to the power n. Now let us come to Euler's formula and how we are going to use it in this particular problem. This is e to the power I theta equals to cos theta plus I sin theta. And cosine theta is simply the real part of e to the power I theta. We can apply this in our series because we have e to the power I pi by 12 equals to cos of pi n by 12, and we are going to apply that. So let us go ahead and see how it turns out. Now, if we are going to convert it into complex form, we first need to write down the series and identify the cos of pi n by 12 term. Replace it with the real part of the exponential, which is e to the power I pi n by 12, like this. And now we can simply take the real part outside of the summation because everything else is simply a real number, right? So this is our final form. And now we can proceed from here, and it's going to be very easy from this point onwards. In order for us to relate this to the initial identity that we found, we are defining a complex variable z, and this complex variable z is going to help us rewrite this entire series in terms of the identity we found. So write down minus 1 whole to the power n e to the power pi n by 12 by 5 to the power n and take the power n outside and then define z as follows. Now we apply the formula we had found out earlier. And in doing so, we simply write n square z to the power n, which we found out was z into 1 plus z by 1 minus z whole cube. And therefore, our series, which was simply this, is simply the real part of z whole into 1 plus z by 1 minus z whole cube, where z is as defined earlier. Substituting the value of z now will give us our final answer with some simplifications in place. So this is the final value, and this is going to be the final real part. You can simplify by multiplying 5 cube first, then taking a few things common. I'm going to show a little bit of steps here, but not everything. And this is going to be your final representation in terms of the real part. We need to find the values of the trigonometric functions, sine of pi by 12 and cos of pi by 12. And pi by 12 is simply 15 degrees, so you can use half angle formulas to find out those values. If you do a bit of calculation, you should find out the following values of cos of pi by 12 and sine of pi by 12 using your half angle formulas. And once we have these two in place, we can find out e to the power I pi by 12 using Euler's formula. Now, when we put these values back in the series, we get our final answer. So after a bit of simplification and working with these radicals and fractions, you are going to get the huge and humongous answer. And it's minus 14400 and then a lot of stuff here. But anyway, this is going to be your final answer. If you like this video and are new to the channel, please consider subscribing and also dropping a comment to let me know how you like the video. Thank you.